This lesson is a lesson on symmetry and rotational symmetry. Similar things, but they are different. And it's kind of a tricky thing to learn. But we're learning about this in geometry, so let's get started. Symmetry, let's triangle here, would be trying to find a line, an imaginary line that you could divide a shape in half, and you could fold the shape on top of itself, like I remember in school called a mirror image. So if I rotate this triangle, I could draw a line right here, and that triangle could be folded right on top of itself. So it does have a line of symmetry. I believe it only has one. So I'll just write that next to it here. This next triangle here has more than one. I don't know if you can see that yet or not, but there's a line here. There's a line here of symmetry. And there's a third one here. So this triangle has 3 lines of symmetry. The pentagon, I believe, has a few more. There's one here. There's one here. I think you're getting the idea. There's one here. There's a 4th one there. And there's a 5th one right there. So it actually has 5 lines of symmetry. Alright, rotational symmetry is a little different. I take this triangle. I don't know if you can see the little green dot above the triangle, but what I'm going to do is rotate it 360 degrees and look for any moment during that rotation that the shape will be right on top of itself from its original position here. So as I rotate it, I'm looking to see if it will be right on top of itself before I get back to where I started. There's no moment during that rotation where that triangle is on top of its original position. So it has an order of 1, and having an order of 1 means it has no rotational symmetry. So let's get rid of this. Let's look at this triangle. As I rotate it, there's one. Notice the green dot hasn't made it back to its original position. There's 2. And then there's 3. Since it has an order of greater than, I should say, than 1, it does have rotational symmetry. Let's bring the pentagon over. Okay, here we go. 1, 2, 3, 4, and then it's back on top of itself. It's completed the rotation. So it has an order of 5. So the pentagon and the equilateral triangle have rotational symmetry, and the green triangle at the bottom, the right triangle, does not. Let's try a couple problems out here. Draw 2 shapes with exactly 1 line of symmetry. Alright, I think I can do that. How about a triangle like that, because it has one line of symmetry right there. Would you agree? Can you think of another? I wonder if I can think of another. Oh yeah. How about a trapezoid? It has one line of symmetry. Let's look at the next set here. Draw two shapes with exactly two lines of symmetry. All right. Well, I think a rectangle might work, because it would have one here, and it would have one here. That would have two lines of symmetry. And I don't know if you've thought of this or not, but how about, remember what this is? I believe it's a rhombus. It would have one here. It would have one here. So they have two lines of symmetry. All right. Draw a shape with no lines of symmetry. I think I am going to draw an obtuse scaling triangle, and I believe that would have no symmetry at all. On to the next problem. Draw a shape with rotational symmetry of order 1. Okay. I actually had an example of this earlier on. Do you remember it? But I think I'm going to try something different. I think I'm going to try my trapezoid. Because if I rotate it, watch the green dot, it will never, ever be on top of itself until I get all the way back around. So that has an order of 1, so it would have no rotational symmetry because it never is on top of itself during the rotation. Draw a shape with rotational symmetry of order 2. Did we do that one at all? Can we do that one at all? I'm going to draw a shape I think that has one. And we've drawn the shape before. Group it here. Okay, watch that green dot. Nothing yet, nothing yet, nothing yet, nothing yet. There's one. And if I work my way back around, it has another one. So it has rotational symmetry of order 2. Alright, now we're going to get on to a tricky one. Draw a shape with one line of symmetry and an order of rotational symmetry of 1. Have we done this before? Actually, one of my shapes I showed you earlier on, actually I believe does this. Let's find out. I think that right triangle does that. Let's find out. Okay. Let me group this. Group. Okay, let's do one problem at a time. Let's figure out if it has a line of symmetry first. So I'm just going to see if it has a one line of symmetry, doing one part at a time. And I remember doing this, and it does right here. Okay? So it has one line of symmetry right now. Excuse me. Now let's do the next part. Order of rotational symmetry of 1. Remember, that really means that it doesn't have rotational symmetry. The only thing that's going to happen is that as you rotate it, it's going to go a full circle and then land on top of itself again. So that would be an order of 1. So it would, which means it has no rotational symmetry. So I'm going to rotate it. You could do this by moving your book, and there it landed on top of itself again at the very end of the rotation. So that shape would work. I hope this has been helpful to you. This is especially a rotational symmetry can be kind of a tricky topic for people to understand. Um, do some research on this if you need to, or ask me some questions. But make sure you understand it, because you will see it in your future. And also make sure you understand symmetry as well. Hope this has been helpful to you.